All right, everyone. Today we're going to go ahead and finish up the 10-2 notes on arcs and measuring angles and arcs inside of circles here. And so yesterday we did talk a little bit about minor arc, major arc, and semicircles. Um, Again, guys, an arc is a part of a circle defined by two endpoints. So here, P and R, there's two arcs that could be defined by that because we go clockwise or counterclockwise from P to R. So um, a minor arc, guys, that's the shortest arc connecting the two endpoints. So the minor arc PR would be the one highlighted in red here that you can see the mouse is kind of going over. Okay, the major arc, that's the longest arc connecting two endpoints. So the major arc would be the blue arc here. Okay, the blue arc is the major arc. So let's go. This here would be our major, and the red one we said that was our minor arc, right? And so the measure of a minor arc is less than 180 and equal to the measure of its related central angle. So as you can see in this diagram here, arc AB, that's a minor arc. It's less than 180 degrees. Okay. And the measure of that arc is equal to whatever that related central angle is. So obviously that angle, that's less than 180. So that would be a minor arc. Okay, guys, major arc, as you can see in the diagram here, they describe it using three letters. So you know we're talking about the major arc because it goes from A, then to D, then to B. So the major arc here, A to D to B. Right? And the measure of the major arc is greater than 180 and equal to 360 minus the measure of the minor arc with the same endpoints. So we would take, whatever angle ACB is here, whatever this angle is, we go 360 minus x. And that's the measure of ADB, 360 minus x. Okay? And guys, a semicircle, it is an arc with a measure of 180, measure equal to 180. So a semicircle is an arc with endpoints that lie on a diameter. So here in this example, A, B, those endpoints, that's a diameter. So ADB is a semicircle. Okay, equal to 180, half a circle. All right, so let's use this information to classify arcs and find arc measures. Okay, GJ is a diameter of circle K. Identify each arc as major arc, minor arc, or semicircle. Then find its measure. So guys, this segment GJ, we're told this is a diagram. Okay, so that means this arc here, just highlight this arc GLJ, which is one of them we're trying to find. Okay, well, if GJ is a diameter, then this would be it'd be equal to 180. The measure would be equal to 180, which would make it a semicircle. Okay. So GLH, that's the next one, or I guess I'm kind of working backwards here. I was just going off what we were given. So GLH here, G, you gotta go in the direction of L all the way around to H. So that arc, there highlighted in green, well, that's a major arc. And if you guys remember, to find that measure, it's equal to 360 minus that minor arc of 122. I gotta get my calculator out here, guys. You know I'm not good at arithmetic. So the measure of arc GLH is 238 degrees. Okay, which of course is greater than 180, which is the definition of a major arc. So GH, guys, well, that one's the easiest, and of course, save that for last. So GH, we know it's the minor arc, because we don't use 3 points here. And so measure of arc GH, that's equal to that central angle that's associated, 122 degrees. All right, so congruent arcs are arcs in the same or congruent circles that have the same measure. So if the central angles are congruent, 1 and 2 here, then the arcs are congruent. And conversely, if the arcs are congruent, then the angles are congruent. So that's the summary of theorem 10.1. I guess we could read it. In the same circle or congruent circles, 2 minor arcs are congruent if and only if their central angles are congruent. So it goes both directions, as we discussed there. Okay. So find arc measures in circle graphs. Refer to the circle graph, find each measure. All right, so the measure of arc CD, so we'll be taking, that looks like the volleyball piece of this chart, CD, so we're looking at that arc, which of course we would need to find the central angle for, guys. Using a pie chart, okay, we know that section, that volleyball section, that is 18%. Okay, it is 18% of the whole circle. So it's 18% of 360 degrees. Okay, well, so if you're trying to find the measure of that arc, that's going to be equal to, well, 18 is a decimal, that's 18% as a decimal is 0.18 times 360. Okay, 0.18 times 360 is 64.8 degrees. That's the measure of arc CD. Okay. Measure arc BC. So if we look at BC, BC is talking about track and field here. It's that piece of this pie, which is also 18%. So those arcs are congruent. So BC must be 64.8 degrees as well. Okay. Guys, adjacent arcs are arcs in the same circle that share exactly one endpoint. So HJ and JK, they share the endpoint J, so those would be considered adjacent arcs. Okay. And guys, the arc addition postulate, just like segment addition and angle addition, as you guys can even picture this as angle addition. If you look here at these central angles in this diagram up here in this example, if you looked at those central angles, okay, so measure angle 1 plus measure angle 2, that would be the measure of angle HMK. Wait, so then it would make sense that if you took the arc HJ, added JK, you would get the arc HK. Okay, so that's what postulate 10.1 says. It's the arc addition postulate. Measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So measure arc XYZ, if you want that whole arc, well, find the measure of each arc individually. Arc YX, ZY, add those two together, that makes your whole arc. Okay, so it just follows like the segment addition postulate and angle addition postulate. All right, so first thing, we want to find arc AED. Well, let's locate that arc A to E all the way around here to D. So if we're trying to find the measure of that arc, we need to add two arcs together. So 63 plus 90, okay, can't think it right at the same time, that's 153 degrees. So that's the measure of arc AED. Okay. Guys, here, hey, we got to use some first semester knowledge. So we're going to be finding where we need to know this. So we know these angles, these are vertical angles. So this is a 63-degree angle. Those angles are congruent. They're vertical angles. All right, we're looking for arc ADB. I just wanted to make note of that. So A to D and around to B. So we know this arc is 63. We know this arc is 90. We know this arc is 63. Obviously, we're going to add all three of those together, but we need to know still this arc CD. We don't know what it is, okay? Because we're going to have to add all four arcs together. All right, so using a little bit of, hey, we know that's 63. I guess we didn't need to use vertical angles because we know this whole piece, okay, well, that's a semicircle, so it's all 180. So this whole piece I'm going to highlight with black. We know all of that is 90. Okay, how do we know that? Well, we know that this part over here is 90, and this is a semicircle. Okay, so we could just do 90 plus 90. 90 plus 90 plus 63. And we get what, 180 plus 63, 243. Could do it that way. Again, I'll show you guys that again. So to clear that up, because I kind of went two opposite directions. So we obviously know 63, check. We know 90, check. Okay, this piece here is a semicircle, meaning it's 180. The leftover part here, that's going to be 90 as well. So we got a 90 check, we got a 90 check, and we got a 63. 90 and 90 is 180. 180 plus 63, that's our 243. Okay, guys, sorry if there was a little confusion there. I realized I kind of started one way, and then this way occurred to me as I was going, hey, this makes a little more sense. Okay, certainly could have done it the other way, but would have been more work and probably a little more confusing. So arc length, guys, key concept here. The distance between the endpoints along an arc in linear units is the arc length. So as we learned circumference, that's that linear distance around the entire circle. Well, arc length is just the linear distance of an arc. Okay, it's that portion of the circumference. And so the ratio of the length of an arc L to the circumference of the circle is equal to the ratio of the degree measure of the arc to 360. Okay, so guys, they take this proportion, that's what all of this just set up, that proportion. Okay, if you want to solve it for L, which is the length of your arc, multiply by 2 pi r. That is going to give us this formula. I will give you this formula. You make note of it. I'm going to give it to you. This is your formula for arc length. I'm not a big fan of showing you guys the proportion piece because, hey, it just turns into this more useful formula. Okay? And so I'll give you guys the formula, and that's how I'll solve these next couple arc length problems. Okay? Oh, worth noting, and maybe I didn't bring it good enough attention. Guys, x, that's the degree measure of the arc. Measure that central angle, or the arc, which is, of course, the same. Okay, so we're going to take that formula. L equals x over 360 times 2 pi r. Okay, Remember we talked about we're always going to use pi is 3.14. Okay, so for those of us who don't have that pi button, it's just easier. We all use 3.14. All right, so find the length of zy, round to the nearest hundredth. So arc zy, that's this arc here. So that arc is going to be x, which is the measure of the arc, 75 degrees over 360 times 2 pi r, which is 4 times 2 times pi times r. Okay, and so you guys can plug this all in at once. So 75 divided by 360 times 2 times 3.14 times 4. Plug it in just how I read it. In fact, that's what I'm going to do right now. 75 divided by 360 times 2 times 3.14 times 4. 5.23 repeating. That's 333. So the nearest hundredth, guys, that's 2 decimal places around here. So arc length is 5.23. Our units are inches. Again, it's a linear measure. Okay, so here we're trying to find zy. Again, guys, we're given that the diameter is 10 centimeters. In 10.1, we know the radius is half of that, so 5 centimeters. That's just because our formula has r in it. All right, so the arc length here is x, the measure of the arc, 10 degrees, 130 over 360 times 2 times 3.14 times r, 5. So 130 divided by 360 times 2 times 3.14 times 5. 11.338 repeating. My calculator. Small. Okay, so nearest hundredths, 2 decimal places, we'll round that to 11.39. This time our unit is centimeters. Okay, so your 10-2 homework here, 12 to 40, just doing the evens. All right, everyone have a wonderful day.